you again for attending today's webinar. I'm Tyler Benz.
I'm Chris Grove.
And I'm Dalton McGowan.
And we're going to be covering a little bit about wastewater misconceptions today. It's going to be a little different than our past webinar series, as we're going to cover 3 different topics, but all pertaining to some of the most common treatments and also questions we get throughout the course of those treatments. Real quick, like I said, I'm Tyler Benz. I'm the technical service rep, as you see there in the map in orange. I cover primarily the West Coast all the way through Wisconsin.
I'm Chris. I cover the blue section, pretty much from the tip of Michigan to the bottom of Texas.
And I'm Dalton. I'm covering the East Coast, which is the green section of the map.
So throughout this presentation, you're more than welcome to ask questions. The chat is active in the right side. Feel free to say hello, things like that. If there are any questions, though, that do come up after the fact, or if there are any other questions not pertaining to the topics today, you're more than welcome to reach out to whichever rep your territory falls under. Real quickly, just a quick overview of what we'll be covering today. Like I said, it's going to be some of the more common types of treatments, those being foaming and foaming filaments, Midge Flies, and upside recovery and toxicity issue. During those, we'll do a brief overview of what in fact those are, how treatment entails, and once again, misconceptions associated with recovering from those sort of ailments. And certainly throughout this presentation, we'll be, like I said, covering a lot of the treatments we do when working with these sort of challenges. So you can see there, we'll be putting a few different pieces of information pertaining to the products that we commonly use to treat these ailments. Once again, for those who aren't familiar with us, we're Aquafix Wastewater Labs. We're based out of EW-Madison Research Park here in Madison, Wisconsin. A lot of the work we do all revolves around wastewater microbiology.
And to start, one of the most common issues that we have and we get from our operators is foaming filaments. There are many different types of foaming filaments. We're going to specifically focus on Nocardia and Microfix. Here's some information that kind of gives you a little bit of an idea of how these filaments come about. Generally, it's the environment that we create that's going to exacerbate a certain type of filament. Far left, you'll notice the foam is a little more white and billowy. That tends to be more Nalo and Nocardia-like organisms. Far right, the more stable, more dense, the hardened type foam is the more Microfix. Microfix tends to thrive in temperatures that are a little bit lower. Nocardia likes higher sludge ages. Both, though, thrive in those fat, oils, and grease environments. There are a few details going to the left on the pictures that give you a little bit of an idea, too, of how they can come about and some of the details of how to identify them. One of the best ways to identify them, though, is obviously doing a microanalysis. Common issues that they cause, generally the biggest part, obviously, is the foaming. And again, being able to identify it visually is a good way to do it. Get a microanalysis, knowing exactly what you're dealing with, allows you to get a better understanding and a more direct treatment. Beyond that, bulking, nutrient removal, what other things have you guys seen?
Anything, once again, like Chris said, a lot of poor settling characteristics, underlying issues like nutrient removal, all that sort of thing. And really the biggest thing is certainly the foaming. That's never going to go away unless you do take action, especially if you don't control your fats and greases. That issue will continue to persist. That foaming will get worse. So you're going to start getting clogging of your, any sort of instrumentation. DO probes might get bound. You're going to get inaccurate readings. A whole host of issues when dealing with this issue, and no action, they're always going to continue to get worse.
Yeah, and a lot of times the foaming is kind of the visual indicator that something's going wrong in the aeration basin. So it's kind of like the last thing of like, there are so many filaments, they're kind of coming up into suspension.
Aesthetics could be a thing too. A lot of operators obviously take pride in their plants, wanting them to look good, take tours, that kind of stuff. Having the foam is just unsightly. Also, if you look to the right, it can get really bad to the point where, like Tyler brought up, it can start having mechanical issues and creating, oxygen diffusion issues, that kind of stuff, DO issues. And as these guys said, it just leads and points to an underlying issue. Here are some common foaming solutions that operators take. Chlorination is a very popular one and can work to a point, but it's an extremely complicated one. One, because it's a dangerous chemical to be using, and you're using a chemical in a biological process that's just already detrimental. What do you see?
Yeah, it's just like Chris said. It's a very small window you have when using chlorine to treat filaments specifically. On the lower end of the threshold, you're not going to have any action. You don't use enough. You're not getting any killing of the filaments, anything like that. Or you use too much, and you start essentially killing off all the good bacteria as well that you've spent weeks preparing, weeks growing, and really relying on that to do all the aspects of wastewater treatment. You're essentially just killing that off with chlorination.
Hosing it down is an extremely popular one. I've seen operators put spray systems over the top of their basins because they deal with so much foaming. Again, it's easy, it's low effort. If once you get it set up, it's pretty straightforward. And I mean, obviously you can just use processed water as it comes back through the return. Getting to the end of this, it's not going to cure the issue. In fact, it can exacerbate a little bit, but at the end of the day, it still isn't going to address that underlying reason why you're having foaming in general.
And the biggest thing with those first two solutions you see are under the cons list, fragmentation is a really big issue. So especially in the area of chlorination, where I always tell operators when using chlorine for these specific issues, is that it's essentially like taking a worm, rather than cutting it in half and killing it, you essentially get two worms. So while chlorination may give you some temporary relief, in reality, you're essentially doubling, maybe even tripling your population that way.
Leaving it alone is a cheap and again, the lowest probably effort out of the three here. Working back to the other two, you're always going to still have the filaments in your system. You're not going to get them out. It's going to be a consistent issue. And the foam generally is always going to be a problem by the hosing it down and leaving it alone. The two products we use specifically to treat FOGs and incoming grease that usually lead to these type of filaments is our QuickSymL and our Foam Buster. QuickSymL is essentially an enzyme that reacts on long chain fatty acids, breaks them down into smaller chain fatty acids, which then are more metabolizable by the native biology. That's going to be the key, because the goal is to create an environment that's going to support and encourage the growth of good bacteria over filaments. Though there always will be some amount of filaments in your mixed liquor, in your biology, the idea is we're creating an environment that is going to support and continue to grow the good bacteria, along with our Foam Buster, which adds basically as micronutrient to encourage the uptake of the fatty acids created by the breakdown of the grease. Both are designed essentially, again, to one, boost native biology, and two, create the environment to sustain that good biology so that we can avoid the foaming and avoid any kind of filamentous breakout that leads to the foaming. All right, we're going to get to some frequently asked questions specifically about, again, the fats, oils, and grease filaments. How long does treatment take? Generally, that depends on, one, your plant type, two, the extent of the issue. Can be a lot of issues when it comes to upstream processes that can be sending you a lot of grease. But generally, we try to do it on sludge ages, and we work through that. A lot of our dosing can take, heavy on the heavy end for 30 days and on a maintenance end for 60 days. But at the end of the day, really learning about your process, what your challenges are, is going to give us a more specific diagnosis and ability to give you a good prognosis of when we're going to get that figured out. How you'll know it's working under the microscope is the easiest way. Visually, it's not going to get rid of the foam right away as it's already established. The foam itself either needs to be vac trucked off, or it's just going to be there until it just gradually stops making more foam. Is that what you guys would agree?
Yeah, and really tying it into how long this treatment will take and how will I know it's working is, as Chris said, we really want to focus on matching your sludge age as best as possible. So typically, we want to look at about the first two sludge ages, one or two sludge ages. That's where we want to see the most microscopic differences. That tells us that the treatment's taking hold, that we're able to start removing these fats and grease from the system. Then the final stages, around day 30, 45 or so, is when we then start to see the visual impacts, where you're starting to get these filaments out of the foam get that foam out of the system.
Can you use one or the other? Generally, you use them in tandem because, as I explained before, they work in one leads into the other. So being able to break down the substrate more completely and then balance out what nutrients are coming in with that broken down substrate, which creates more volatile acids, is going to make your biology be able to keep that balance of BOD to N to P ratio more in that wheelhouse where you sustain and grow good bacteria, which obviously leads to better BOD removal and breakdown and a healthier plant. Preventing future outbreaks. I mean, we had a big discussion about this. Where does fats, oils, and grease come from? They come upstream. You're not necessarily dumping it in there unless you have unless you take in a lot of septic tanks or you have other sources of incoming flow that you may have agreements. And some cities do. But usually it's just go upstream, monitor your lift stations, work with your collection systems team if it's not with you. And also, I know most cities do pre-treatment programs where you should maybe get involved with whoever works with that and see how you can mitigate grease coming into your system. And we have other solutions too.
Yeah, and future outbreaks, the biggest thing is monitoring, right? So foaming, as we talked about, is kind of the symptomatic problem of something in the aeration basin. So we're happy to work with you, work with the lab and kind of our lab and figure out what exactly is going on in the aeration basin, if there are any changes that are coming up, and really being able to forecast or kind of figure out if there's anything that might impact down the road with foaming specifically.
Mechanical adjustments can also include just keeping it out of your system, headworks type stuff.
Grease traps.
Yeah, making sure your community's grease traps are working correctly or keeping it on there. Obviously, we know a lot of operators in their relationship with business owners can be not the closest. They don't communicate that great, but that would truly help. Other mechanical adjustments you can make is get an understanding of your sludge age. Mallow loves old sludge age, so that's an easy way to just make a simple adjustment in terms of being able to waste out some of it and bring in younger bacteria, again, to build that solid foundation and that healthy bacteria. Chlorinate and use our bioaugmentation products for sure. The idea, though, in a biological process is to not have to use chemicals that are going to impact the actual bacteria that are doing the work for you. Our products are, meant and designed to work with your bacteria, not only to optimize your system, but obviously avoid these foaming and these bulking and these events that can plague operators. I've not really had a lot of experience where an operator called me and goes, "Hey, I'm using this and chlorinating." I don't know. Do you guys run into that a lot?
It's going back to what I said earlier, where it's a very small window. It's absolutely possible, but it's really got to err on the side of caution, just because, as we noted, there are a lot of cons to it. If you can find, that sweet spot, so to speak, that would be ideal. Typically, we recommend, I believe it's about 2 to 3 ppms in the RAS line is usually a safer assumption for chlorinating in your plant. It's once again, you got to err on the side of caution when using it. And real quick, before we hop into the next section here, we do have a question from Simon in the chat here. Does Foam Buster contain phosphorus? So it does, but in very small amounts. What we're doing with Foam Buster is, as Chris said, where Quicks-ML is breaking those long chain fatty acids into short chain fatty acids, otherwise known as volatile fatty acids. Those being mainly carbon based, we essentially want to alter the nutrient profile so that we can encourage the further uptake of these carbon substrates, of these volatile fatty acids. In doing so, we want to add small amounts of nitrogen and small amounts of phosphorus in the form of Foam Buster to complete that process. It's really working on that idea of 100 to about 5 to 10 to about 1 in terms of parts of carbon to nitrogen to phosphorus. So Simon, yes. Have you ever added Quicks-ML/Foam Buster to a digester? Have fat build up in an industrial cheese production?
I actually have done that, and it can and will work. We can actually do samples on digesters also. One thing we didn't note that foam is probably originating, your filaments are originating in your aerated process. You're essentially wasting them in there. To get more towards the point, yes, you can use Quicks-IML and Foam Buster in there. Get this one's a little more specific. Give us a call. We can chat a little more about it. And if needed, we can get the lab involved. A lot of times with a digester, because of how they hold and how they sit, it's best you vac truck it off and then start working with these solutions to improve it, because the foam will just sit and build up and then work upstream.
All right, so we'll move on to the next section of our presentation.
Awesome. Yeah, thanks, Chris. Next, one of our more common issues are midge flies and redworms. So kind of being really tied hand in hand, the larval stage and the fly stage, and some of the issues they present in wastewater systems. The biggest one, obviously, being the issues that they're having with our mixed liquor in our systems. So a lot of the times we'll be able to indicate or see that there are redworms in the system. A lot of times plants are in the clarifiers, they're seeing them around walls, things around those lines. The biggest one being what they're doing to our mixed liquor and aeration basin, which we might not be able to see right away. And I think the biggest complaint we hear from operators or anyone who's working in the plant or visiting is what they're doing for building up in sheds, indoor buildings, and kind of the pest side of the problem. Those are kind of some of the biggest two issues that we'll run into. Obviously, the biggest for operation being the impact they have on our mixed liquor, and then really just the annoyance of having flies, birds. Chris, I think we were talking today about spiders being in those buildings, getting built up, and really being a hazard-ish to kind of enjoyable daily life. I was out in Pennsylvania, and the guys were talking to me about just how bad they're on their trucks at the end of the day. And it's really just like having to deal with that is something that just kind of continually comes up. And that's usually the good way to figure out if you have them or where kind of they're in. Other things, though, they can end up in the influent. They can end up in TSS depending on how bad the infestation is. And that's something we want to also really address, because we want to make sure that we're not violating any permits, addressing the issue with the root cause being the redworms in the system to get those midge flies down in the system. So some misconceptions with treatment, the biggest one being misidentification. So knowing what's in the system, knowing what kind of organism, either in a larvae stage or in that fly end stage, what exactly it is, what is going to be our next step to helpful and beneficial treatment. Kind of the next one being chlorination. So a lot of times we'll see plant operators, kind of what we were talking about with filamentous foaming. Chlorination is not always going to be the best option depending on where they are in your plant, because we can't really chlorinate our activated sludge. We can't chlorinate our aeration basins, which is usually where they're starting off. And a lot of the times, depending on what your final disinfection is, they might also already be in your chlorination contact chamber, which obviously isn't doing enough. And the amount needed to knock them down or really eliminate them is quite high. One of the next ones being there's a direct cause for infestation. Because you have them doesn't necessarily mean there's something going wrong in the plant. It just means they found your plant some way. I'm sure you guys have had something where they've just showed up after 20 years and kind of don't know how.
Yeah, we've been seeing a lot, especially with the weather we've been having this year specifically. A lot of I&I, a lot of rainwater, a lot of stormwater, all of which can bring any amount of larvae, not just redworms. And that's why, like Dalton said, misidentification is a common issue, because you can get not only redworms and midge flies, but you can also get something like Tubifex, even snails, a whole lot of different organisms. So really being able to hone in on exactly what type of organisms you're dealing with will help address the issue. But unfortunately, it's one of those things where no plant is essentially really safe from an infestation. It can happen in the best of plants and the worst of plants.
Wastewater plants provide the optimal spot for a redworm to incubate. You have organics for it to eat. You have the ability to, like we're going to talk about soon, cocooning. And the water generally doesn't get extremely cold, which again, we'll touch on later. And usually we effluent to a slower moving water body. They're related closely to a mosquito, so you're going to be susceptible because of just where you effluent and the idea that these things are a species that have been around a very long time. They're going to figure out what works. And again, that also leads to understanding why you can't necessarily eradicate them.
Yeah, and that kind of goes into the next one, wasting. It's really hard to waste them out, if not impossible to waste them out in the system. They're going to be, as we kind of talked about, in most places that are habitable. So wasting them out, we're only really targeting a certain portion of the plant with that. And they are, unfortunately, in your only plant effluent. A lot of times we'll see them. If you have like an indoor UV chamber, an indoor chlorination tank, you'll see them maybe most populous in there, or in like a clarifier, and then you'll kind of know that they're upstream. The biggest way, as we kind of talked about, mixed liquor, losing mixed liquor numbers for no apparent reason could be an indication with what's going on. And obviously treatment then has to take place with losing mixed liquor from the worms. So
And a lot of times you see in your samples, when you take a sample, do a 30-minute sample, you see them. Just because you don't necessarily see them anywhere else, they're in there. That is the best time to take action before they get to the point, like Dalton says, where they're starting to impact your mixed liquor, because then you're infested and then you're in trouble.
yeah. So then we have kind of this nice graph that will kind of show, Venn diagram kind of shows the couple different organisms that might be popping up, the redworms and the tube effects, really working on good identification. One of the big things that we have as a resource for you guys operators is our Secret Life of Bugs, redworms, and other microorganisms that has, we have a really big database. Our lab has put that together over the last couple of years, still always updating it. So it's a really good thing to check out. Keep on like the bookmark tab in the office or in the lab to kind of keep on what's going on, because they are different. Redworms, tube effects, they have different impacts. They come with different problems. I know Tyler had something recently when identification is not always as clear. So we're always there to help work with you and figure out what exactly is going on and what exactly is the problem.
And we have this comparison here just because, as I said on the last slide, is misidentification is really the biggest challenge of it. Redworms are often mistaken for tuberflex worms. As you can see, they're pretty different in nature, but it's very easy to understand how an operator can get confused by them, as obviously they're both worms. So this is a nice helpful chart, like Dalton said. We do have plenty of other resources on our website. You can see in the chat there a link to our Secret Life of Bugs blog post that has a little additional information on this specific issue at hand. But as always, with any of our materials, if you have any questions or want copies, you're more than welcome to reach out to us.
Yeah. So kind of when we're looking at treatment of midge flies and redworms, the biggest one is we want to target the redworms themselves. That is the larval stage. So we kind of do a two-prong approach with our Midge Fly Complete product, which is Larvazyme and Aquafix. So Larvazyme is going to be kind of the heavy hitter when it comes to degrading the cocoons, making the redworms more available to the larvicide, which is the Aquafix product. So Aquafix being US EPA registered as a biological larvicide. So we're using a bacteria to kind of naturally remove them and get them out of the plant. So working in tandem with these is going to be our best solution for getting them out, and your best solution in the plant. Typically what treatment looks like is 4 weeks of heavy dosing, so twice a week, and then going on to a maintenance dose to kind of keep them down. Because as we were talking about it, we're making treatment plant is a good environment for them. We really just want to keep their numbers down as much as we can moving forward.
And especially going off the point where we talked about wasting them out and how that's not possible. That's where that Larvazyme comes in handy. It's because they'll find nooks, crannies, any sort of crevices, and especially if you have an older wastewater system or any valves, any piping, anything like that, the redworms will find those areas, and that's mainly where they'll populate when it's kind of lower flows, more stagnant water, and obviously plenty of food. So that's why we definitely want to use Larvazyme to help open up the doors, essentially degrade the sludge that they hide themselves in, as well as the cocoons themselves.
Midge Fly Complete is the best way biologically to control redworms without having any impact on your effluent, any impact on your biology in the system, or any impact on your mechanical operations.
Yeah. And the big one being on that, they don't gain any tolerance to it. So it's always going to be effective. They're not going to have resistance to it over time. It's going to be effective time and time again if it's a reoccurring thing. So it's really going to be the most effective. So kind of going into some frequently asked questions. How long will treatment take? Kind of as we talked about with the fog filaments. Treatment, like we can depend on the plant. Most of the time we want to treat early before they pop up, and that 4-week initial dose. And then we recommend usually 2 to 4 weeks after, or depending on one, until we start seeing the numbers that we're looking for. One of the best times to treat, a lot of the best times are going to be before you start seeing really heavy numbers of redworms and midge flies, in addition to, I would say, depending on the part of the country, early spring, late winter, when those temperatures start to go up. What are you guys seeing when one of your plants recommended to start treating?
Ideally, if you have a good historical, idea of when you typically start to see these outbreaks. Otherwise, if you maybe are new to the plant or haven't dealt with this issue before, I always tell operators it's a good idea, have a feel of when temperatures start getting about 55 degrees Fahrenheit. That's a really safe time to start treating and start getting ahead of it, so that you don't have this issue continue to persist, and you can even use a lot less product once you can get ahead of it.
Yeah, right. So it's kind of being on that maintenance dose rather than being on that heavy twice a week dosing. Do they go dormant, and does the cold kill them? As being kind of that organism, the cold slows them down. They start slowing down in the winter. They might still be in your plant, depending on where you are in the country, what the temperature is. So unfortunately, like a really hard cold snap might lower the numbers, but they might just pop up again right early in the spring again. Kind of the next question that we run into is, can I use Aquabac alone? A lot of times what we want to do is use both products in tandem, because as we were talking about before, the larvazyme is going to be making Aquabac a lot more efficient and a lot more potent, and opening up kind of what we're looking for when we're removing the redworms from the system. What do you guys, any
Generally,
thoughts
we
on
need
that?
to expose the redworm to the Aquabac. The less exposure, the less effective the Aquabac is. A larvazyme is exactly what does that.
Yeah. What types of facilities are most acceptable? Kind of as me and Tyler were talking about, any facility is really going to run into these problems. I would say the biggest ones anywhere in kind of the southern part of the U.S., warmer temperatures. Doesn't necessarily have to be though. I have a couple of plants that have indoor facilities or in indoor basins. Anytime we have that warmer water temperature coming in, we're going to run into those problems. Can I treat it in lagoons? Yes, lagoons also are still susceptible with the solids. It's another good home. We have treatments similar, exactly kind of what you would treat with an aeration basin. Just a little
dosing is just a little
bit
heavier, because it depends on the size and volume of water.
Just a little bit dosing instructions, and if you have a lagoon and midge flies, we'd be happy to take a look and start working with you for treatment. What else can midge fly complete treat? It is a very select group of flies that it treats. So really it's only going to treat midge flies, the redworms, and then a couple other species, which is mosquito larvae and black fly larvae. Other than that, it doesn't harm or remove any other things from the plant that would be beneficial to the system. Looks like we've got a question from Elaine. Is there any value of maintenance treating during cold weather? Absolutely. So kind of as we talked about, the cold weather is not going to fully remove them from the system. So using Aquabac and larvazyme during the winter months and that lower dosing is really going to keep their numbers really low. You might avoid, or you most likely will avoid, a really heavy spring hatch when you get that first warm weather snap, which is really going to be beneficial, keeps populations down. I guess, do you have anything else to add on that?
That's
one?
exactly it.
Yeah.
You're going to avoid and basically mitigate any kind of major infestation you're going to have. You still may, they're very good at what they do, but reality is you're going to make it less. So very much so. If you have any kind of activity, there are places that dose year round, and just stay ahead of it or you're going to get behind it, essentially.
Absolutely.
All right, and with that, thank you, Dalton. We're going to hop into upset recovery. Now, this one's going to be a little different just since there's obviously a lot of different reasons and causes for upsets in wastewater. So we'll do our best to kind of generalize them and certainly give you solutions then to recovery. As I noted, a lot of different causes of toxicity that lead to upsets. Really regroup them in kind of three different categories, that being chemical. This one's going to be more so related to a lot of those working in industrial facilities or downstream of that. We're going to be dealing a lot with quats, PAs, and different types of cleaning agents. Other environmental concerns, though, are going to be mainly on the municipal side, where you're dealing with a lot of I&I, high and low temperatures, and a whole host of even Midge Flies. Mechanical issues, that's really obviously going to be any plant, whether you're dealing with high VOD loads, high dairy loads, or for those facilities that are mainly seasonal, where you get low flows at certain points of the year and high flows at other points. That any of these inconsistencies is what harms biology. Biology loves consistency, so anything going out of whack is certainly going to cause some form of issue, some form of upset. And then certainly there's other mechanical issues, just like valve and pump failure. Lack of storage is a big one, especially for smaller municipalities where you don't have the luxury of like an EQ tank or retention ponds, that sort of thing.
I think one of the biggest upsets this time of year is tourism. So if you're in a town that gets a lot of people, a lot of times that overloading or underloading past tourist season is really hard to deal with. Some of these things that we're going to talk about can really help with that, depending on where you are in the country.
I'd say lack of storage also includes at the end of the process. If you don't have the ability to waste appropriately, everything's just going to kind of have issues upstream. Obviously not necessarily toxic, but you can create upsets by not being able to waste appropriately.
Yeah, and that's a good point. When I say toxicity, it's really anything that causes an upset. Essentially, that's toxic to any biological organism. So some signs you can start to look out for. If you do microscopy on site or utilize our lab services, a really good and really the first thing you're going to see if you're doing that is going to see poorly formed or damaged flock, a lot of irregularities when looking under the microscope, and certainly settling issues when you come about that. Loss of biomass, kind of similar to the Midge Fly issue, whether that, especially with high I&I, something like that, where it's going to just completely wash out your system, wash out all your good bacteria, your flock, your nitrifiers. That's certainly a sign when you're seeing mixed liquor dropping off.
Cloudy clarifiers.
And I think this year has probably been the worst out in my area for I&I. Can't tell you how many plant flows have like tripled or doubled from I&I, and a lot of times you guys operators don't have as much options to do anything as much as you can with working on I&I projects, but it's a really big issue especially in the spring kind of going forward.
Really how I treat it is anytime I'm dealing with a customer who has an issue, whether it's any version of those toxicities I noted earlier, I'm really going to want to look at how nutrient removal is going. Ammonia is going to be the first sign of any sort of toxicity, or I should say lack of ammonia removal. Nitrifiers are the most sensitive and certainly the most scarce in any wastewater system. So if you start to see ammonia removal not quite what it used to be like, you may be dealing with some sort of toxicity. And as you kind of start increasing in severity of that toxicity, you'll start to see phosphorus removal drop out, and then BOD and COD removal drop out. And once you get to that point, that's telling us that your flock is now starting to be effective. And ultimately, beyond that is complete plant death. So ideally, if we can catch it at that ammonia loss stage, that's going to be better in the long run. Once again, being proactive or reactive. And another note too, with filaments, they'll be able to tell you a lot about a system. I know we talked about Lucardia and Microfrix. Those are more obviously strictly fats and greases, but other filaments like low DO filaments, low F to M filaments, all of which septicity, all of those are going to give you a lot more insight and a lot better of an idea of what kind of toxicity you're dealing with.
The environment, the biology.
Yeah, and really what happens is once you start losing that biomass, the filaments are sometimes better at reproducing and better at taking up that space that you lost from whatever upset happened. Those filaments come in, they're now kind of the more present biological mass in the system because of what happened from the toxicity upset. So that's usually a good indicator that something might have happened at some point. And what's coming in, what type, is kind of maybe that indicator of what happened.
And as you see there, we just put a link to our microorganism database. That is an excellent tool to use if you do have microscopy on site, or if you just simply want to learn more about different sorts of organisms. We cover a majority of the filaments you'll see in really any type of facility. So use that as a good tool to help you kind of build more knowledge about the issue at hand and help you get a solution ultimately. And once again, if you're ever unsure of what filaments you're dealing with, unsure of how your plant's doing, or just simply want to check up, that's what Aquafix is here for. This is our specialty in identifying key organisms, key characteristics, and ultimately providing solutions. So going into the misconceptions about toxicity and the recovery process, we get a lot of the times where it's either, oh, we haven't identified any specific toxins, or our favorite, if you can call it that, is I was assured by production, talking about if you have an industrial user either at your site or upstream, I was assured by production that there's no spill. Those are often really challenging because, number one, the bugs don't lie. We can always take a microscopy sample and tell you, based on what filaments we see, we can identify some form of toxicity. So while someone may say they haven't spilled anything, there's a good chance they could have. Or if there are no identified toxins, there are other culprits for toxicity as well that we noted, where it could be mechanical, could be environmental. It's never just one thing. These issues compound.
Clogged aerator, anything around those lines can lead to issues down the road.
Leads to the next bullet point, the DO probes. That being said, your aerators are there, your DO probes being on them, making sure they're calibrated, making sure they're maintained, because a misreading on that, especially in automatic systems, can lead to really bad toxic environments, which create upsets for sure.
And that's what we say with both Midge Flies and honestly Nicardia foam. They can build up around DO probes, so you can get a bad reading that way. So it's always best to maybe have multiple probes on site. And once again, microscopy can help you because low DO filaments are very quick at showing up under the microscope if there was at all any sort of low DO hit or anything like that. So keep an eye out for those. From there, it's really straightforward. It's just simply increasing your oxygen content. Going further down the list here, no industrial connections upstream of plant. Same thing, once again, there's other drivers of toxicity, so to speak, in wastewater systems, especially if you're obviously been a municipal plant, a lot of environmental drivers. So really understanding your plant, understanding plant history, upset history, all is really helpful in working towards a solution. And then lastly is ammonia removal is the only thing wrong. I just need to replenish nitrifiers. Yes, there are a lot of cases where, as I noted earlier, where the issue isn't as severe, only nitrifiers are suffering. Absolutely, that could be the case, but it's really important to make sure you're doing your due diligence to make sure that there aren't any other drivers in place. Once again, those issues compound. And while one you may be dealing with multiple issues that are, not as high in severity, they do stack. So be sure to keep an eye on.
Yeah, and kind of on that last point, Tyler, like nitrifiers are kind of the most sensitive organisms. So if we're trying to add back ammonia and replenish or ammonia removal and replenish nitrifiers, if the plant still has those stressors in place, stuff isn't the nitrifiers don't necessarily take as well. That's going to continue running issues. The really big thing is remove the stressors, fix the underlying issues of what it is, and then we can kind of start looking at getting those nitrifiers back in, starting with ammonia removal.
And real quick, I'll jump into some of the products we use for the recovery process, all of which are really going to be dependent on which issue you're dealing with. So I'm just going to generalize. Once again, this is something we have plenty of experience in working with. We'll be able to get you the right solution for you. So first off, one of the products we use is going to be Counterplot. What it is a source of bacteria and key nutrients specific to building and strengthening the cell wall of your good bacteria, of your flock formers in your system. In doing so, they're going to be more resilient against not only quats, it's somewhat misleading in the name, so they'll be resilient against quats, but not only quats, PAAs, even colder temperatures. Really, anytime you're losing out on bacteria due to some form of stressor, counterquat can add an additional bacteria while also rebuilding your good bacteria in your system that's already present. Use it a lot with a lot of industries we work with where they have common cleanouts. Once again, being proactive. If you know you have a clean out next week Tuesday, you can start adding counterquat now. Build up that population, strengthen your bacteria, and once that issue inevitably hits, you're prepared for it and you can recover a lot quicker. Furthermore, we have our smart BOD. So this one is going to be more so tied to when we talk about either overloading or underloading. Anytime you have those peaks and valleys in BOD loading, that's inconsistency. Biology, once again, does not enjoy inconsistency. So smart BOD essentially adds in good nutrients for your bacteria, as opposed to something, a lot of operators like to use like glycerin or dog food. All of that is not necessarily even designed for wastewater. And looking at glycerin, I would say it's like giving your plant a candy bar, super high in carbon, some impurities with it. Smart BOD is essentially like giving your plant a well-balanced diet. So focusing on that 100 to 10 to 1 carbon to nitrogen to phosphorus ratio. Smart BOD is exactly balanced for that.
Yeah.
Next up is rebuild. So kind of like I said with the counterquat where it has that bacterial property to it, rebuild is an excellent one where it's just pure bacteria, great for restarting a process. So maybe if you had an issue that you didn't catch early enough and you got either complete washout or at least some element of just flock formers washing out of your system. Great easy way to build back your population quickly and avoid having to source seed from another plant where they may be bringing in a host of filaments. They may not be used to treating similar feed as your plant was.
That's one of the large things with rebuild compared to bringing in other people's mixed liquor. You're not getting what filaments and what issues they're going to bring in. It also builds a lot quicker with what he said, the best bacteria that are going to be the healthiest.
Yeah, and it really, my biggest thing with rebuild is it's great after like I&I, washouts. It's something that can be used more consistently rather than if it's a smaller upset or something that's really just happens more regularly. A lot easier and a lot less planning than having to get seed sludge or figure out how you're getting your mixed liquor built back up, which is really beneficial.
And lastly, here we have our Nitrifier Pro. This one may be familiar to a lot of you as we've done a lot of work in covering it over past webinars. And we actually recently launched this back in the winter here. Nitrifier Pro is, as Dalton said, is really that cherry on top. So the last part in the recovery process. So once everything is kind of set in stone, once you have BOD removal, once you're settling properly, and really all that's lacking is simply ammonia removal, that's where you can then add nitrifiers. Once again, making sure that whatever stressor caused this issue is no longer present. Totally safe then to add nitrifiers. It's as simple as really all it is just a blend of concentrated nitrifiers suspended in liquid. Simply add that to your aeration basins, and within 4 days, we expect full recovery. And I think we're going to add in here just a quick study we actually did this past winter that I find really interesting and really cool. It really showcases how effective Nitrifier Pro is on a larger scale. So in the study, you'll see a 9 MGD facility struggling with ammonia removal in the dead of winter. Once again, another environmental stressor. They were able to recover full ammonia removal within about 4 days. So definitely check that out if you get a chance. Once again, if you miss it or want to learn more about that, please feel free to reach out to us.
Check out our website.
And then so jumping into the last part here is just simply frequently asked questions about really toxicity and nitrification as a whole. Can I just add nitrifiers or can I use a booster dose? Once again, absolutely. If you know that your issue is just about completely resolved and the only last part you need is ammonia removal, absolutely. Same thing with a booster dose. We've had plenty of instances where,
literally, you're right there with your numbers. You just don't need to do that.
Yeah, you're not quite violating any permits, but you do know that ammonia and nitrification is struggling a little bit, certainly can do that. And that's something, once again, we're always willing to work with operators, get you the best treatment for the issue at hand. Can I keep these products on site without active upsets? Absolutely, and we certainly recommend that.
Yeah. My favorite one to recommend, and if I work with you as an operator, is rebuild. It's really the easiest when you get washout, when things that are happening on upsets and you're not maybe necessarily sure. It's going to be a good all around like multi-tool in your toolbox. And then same with, nitrifiers, anything around those lines. Nice thing with nitrifiers though, we can get you it next day. It ships out cold, so we're really quick on getting things when it comes to upset, especially with the nitrifiers that we need.
All of our products have a 2-year shelf life, so
Yeah.
It's one of those things that it's always better to be, once again, proactive as opposed to reactive. Have a little bit on site so that you can start getting ahead of these issues before you're dealing with full-on BOD or BOD removal loss and losing all your mixed liquor that you've spent time building up. And really, that's nice going into the next point here is what proactive measures can I take to avoid future upsets. Once again, with all the other issues we talked about today, is daily microscopy is number one.
Yeah.
If you can get in front of a microscope, it doesn't even have to be daily, as long as maybe once a week, you can get an update on your plant. We always say, or at least I always say, it's like taking your plant to the doctor's office. It never hurts to get a checkup. You can stay on top of it, and any issue, whether it's toxicity, filaments, midge flies, you're always going to see it in microscopy first.
Yeah, and as a lab, we're always happy and more than happy to take a look at sample, really quick to get a sample out to you. We can kind of figure out what's going on. Really easy to keep one on hand, figure out what's going on. If you don't necessarily have a microscope or a lab, we're absolutely equipped and ready to go to start looking at what's going on.
Keeping on those other numbers that Tyler mentioned earlier, your ammonia, you see it start ticking up. You see BOD start ticking up. You start seeing settling start getting worse. Those are just more macro visuals of being proactive and noting when those change, because that means something is trending to an upset.
And getting a little more specific into the products I just covered. So we get a lot of times low counterquad neutralized quads. As I said earlier, when introducing counterquad, somewhat misleading in the name. Well, it works on quads. It also works on PAAs, any other forms of toxicity, not even limited to simply just chemical toxicity. And once again, what it's going to do is apply bacteria and nutrients for your good bugs. So rather than focusing on any chemical upstream and having to adjust the dose based on what's being added upstream, when it's being added, it makes it easy for you to just simply focus on your bugs, focus on what you can control. Because oftentimes, once again, plants sometimes don't tell you if they, have a chemical spill or even if they change products.
That's a big one, is changing products. You can't know with quat binders, etc., what exactly the production is going to be using. So what the counterquat does, it doesn't focus on that. It focuses on making your biology more resilient.
Yeah, it's really a shield, if you will. It adds and it really boosters the amount of stress a plant can take, is kind of how I like to think about it, is whatever's coming in, have it be whatever chemical, it really just boosts the ability to deal with it really well, kind of going forward.
Let's go through some questions here. So let's see. We got, in a typical conventional aeration plant, do you sample from the aerated mixed liquor or anoxic zone? Or is there conventional activated sludge, not aeration? Yeah, so with that, whenever you're taking samples and whether it's sending samples to us or just putting them under the microscope, ideally you want to take from a place where your biology is most active.
Yeah.
That's going to be in an area, most likely your aeration basin, where it's being aerated and mixed the most. And that's where a bulk of your treatment is taking place. So that's what we want to focus on. And that's going to tell you a heck of a lot about your system. Just like taking the fingerprint essentially of a system and getting a full-on report from just a sample.
Yeah, we always want to look at our mixed liquor, and then with our sample kits, what we send out is we send out 2 bottles. So we'll look at our mixed liquor. Same depending on what type of plant you have. If you have an SBR or multiple trains that don't run all exactly the same, we want to look at what's going on at each system, because with biology, SBR wise or whatever kind of plant you run, that's going to be something where it could be different, and we want to figure out what exactly is going on. Also, if foaming is an issue, as we talked about, we want a foam sample to figure out what's going on. So that's typically what we're looking for when we're taking samples, and then especially when you're taking samples in-house, making sure whatever the main issue is, getting that mixed liquor, and then wherever else you want to really take a look at.
That's why we recommend, if you're interested in sending a sample, call us first. We'll work through it, learn more about your plant. We'll make sure it's clear what we want to see and what your goals are essentially with the sample.
Yeah.
Because at the end of the day, we don't necessarily know just by reading this question what exactly you're dealing with, and maybe we want to take a sample from somewhere else. But generally, we make it streamlined, we make it easy. For the most part, you can just get one offline and simply send it in for a general microanalysis.
Yeah.
And kind of going along the testing question. So in testing for quats, what test kit do you recommend for the most accurate information? Off the top of my head, I can't name a specific kit, but this is something that our lab has done a lot of work with in studying toxicity. So that's something, Francie, if you want to reach out to one of us, we can get you in touch with our lab and get you a specific name.
Yeah, they will have that information.
Absolutely. Yeah, I know Dan is our leader of research development at Aquafix. He's done a lot of work with quats and toxicity. He'll be able to get you the exact.
Yeah, he designed the counter quat, so you should have some insight.
So please reach out, Francie, whenever you get a chance today. We'd be happy to help you with that. And real quick, we're going to wrap up. How smart BOD is different from other food sources. I touched on that already, where
balance.
It's an absolute balance. It's 100% bioavailable.
That's the big part.
That's
no
the big
solids are going to be added to your system. It's only going to be food specifically for wastewater biology.
Absolutely. And how quickly will my plant recover? Very ambiguous question. It is 100% a case by case basis, where in the case of, say, you just want to add nitrifiers, like in that first part we talked about, that'll simply take 4 days. But, going on the further end of that spectrum, if you have a complete washout, then we're talking about a full scale rebuild.
30 days, 35. Yeah, it's always gonna determine on your situation. But that's what we're here for.
Yeah, and I think quickly is, how quickly and how well is the big thing. And that's something we're really going to help address, how to do that best and how to do it where we're going to help in a way where it recovers quickly and it recovers well, not just having filaments come in or having some removal, making sure that the plant is back to how it really should be is the big one.
Absolutely. So that takes us to the end of our presentation today. And I apologize for the length of time today. I know we expected to take a little longer due to the subjects at hand, but certainly if there's any questions, like I said, that come up after this, feel free to reach out, shoot us an email, give us a call. We're always more than happy to help. If you want a lab kit, like Chris said, you can order online, or we can help get you set up and get that sent out. It only takes about 2 to 3 days to get a full-on report. I really enjoy it. I think it helps a lot of operators get a little more insights to their system, all of which are going to be able to help you, avoid most of these issues that we talked about and a whole host of others.
Yeah, and it really helps our lab and us get you kind of the right source of treatment. Is the big one with, up-to-date, accurate testing. A couple of days ago, we're able to figure out exactly what would be the best step to treat, what kind of filaments there are, what's going on in the system, and how we can address what's going on, or what changes that you can make to make the system optimized a bit as well. So
absolutely. And with that all being said, once again, thank you very much for attending today's webinar. I believe we'll have it our next one in about 2 months here. Keep an eye out on your email. Otherwise, that's always posted on our website for the
Check out our past webinars. They're all available on our website.
Yeah, if you're joining us for the first time, our webinars are all linked on our website under our resources tab, past events. That's going to be something where we have a lot of different topics, a lot of things covered. Great resources for if you have someone new joining the team, new operators, a really great way to get kind of this on a different scale as well.
Absolutely. Well, thank you, everyone, and have a great rest of your day.